Олег Васильович, можемо починати.
Hello, dear colleagues. My name is Oleg Zabolotny. I'm from Lutsk National Technical University, and I'm glad to welcome you on the 5th Kravchenko's International Conference on Advanced Manufacturing Processes, InterPartner-2023. We hold this conference in difficult times for Ukraine and dedicated to the bright memory of all our defenders. Let's honor their memory and pay respect to the fallen Ukrainian heroes with a minute of silence. Thank you. And now we are ready to start our session 8, Advanced Materials 2. On our session today we have 4 presentations of works submitted to this Slovakia research organizations. First work about structure and thermal stability of vacuum cupro-molybden condensates from Valentin Rebashtan, Anatoly Zubkov, Maria Zhitko, Edward Zuzula, and Olena Rebrova. Second paper is organization of the structure of composite construction materials and the impact on the characteristics on concrete from Hanna Zinchenko, Vitaly Dorofeyev, Natalia Pushkar, Igor Mironenko, and Stanislav Fitz. Third work about numerical evaluation of the properties of highly efficient titanium porous materials from Alexander Pustanoy, Natalia Imbirovich, Rostislav Rydko, Olga Rydko, and Pavlo Sovereign. And fourth, describe the structure and mechanical properties of vanadium niobium added PRIP assisted steel after Q&P treatment with NEA AC3 austenitization from Vadim Zhunadze, Yulia Chabak, Vasily Yefremenko, Alexei Yefremenko, and Maria Podobova. All listed works will be broadcasted now here in this chat and also via the YouTube channel. After a video presentation, I invite you back to our meeting with your questions to authors to discuss presented works. So now we can start video presentation. Please visit links and enjoy.
Hello, my name is Valentin Rebashtan. I'm a PhD student of National Technical University, Kharkiv Polytechnic Institute. I'm here to present you our research. The topic is structure and thermal stability of vacuum copper molybdenum condensates. So let's begin. In the vapor phase, any substance can be mixed at the atomic and molecular levels without restriction or composition. The vacuum condensation method, PVD method, makes it possible to obtain metallic materials that are currently unavailable or at least very difficult to synthesize by melting and casting. These are the so-called immiscible systems, the components of which do not have mutual solubility and do not form chemical compounds in either solid or liquid states. Typical representative of such objects are thin films, foils, and coating of the copper-molybdenum binary system of various composition with a wide range of structure states, including objects with nano and sub-micrometer sizes, anomalous supersaturated solid solution that are not characteristic of phase equilibrium condition, etc. The possibility of more precise control of the structure formation processes in condensates than in melting and casting makes them convenient objects of research aimed at solving the existing general problem of increasing the thermal stability of nano and microcrystalline metals. Composite materials based on copper, like copper molybdenum, copper tantalum, etc., called bulk pseudoalloys, are obtained mainly by powder technologies. They are also produced in the form of films, foils, and coating using vacuum plasma technologies. These materials have high physical and mechanical properties. Alloying of the copper matrix with such refractory materials as molybdenum, tantalum, and tungsten leads to a multiplied decrease in the grain size of the copper matrix down to nanosize. The main problem of nanostructured materials is their low thermal stability. Therefore, the problem of increasing the thermal stability of the initial nanodispersed structure and the corresponding functional properties is an important direction in numerous studies. Previous studies have shown that the formation of strong bonds between copper and molybdenum atoms at the grain boundaries of the copper matrix contributes to an increase in the thermal stability of the initial structure and functional properties of copper-molybdenum condensates. The available information of the role of second phase particles and the equilibrium segregation of alloying element atoms in the mechanism of thermal stabilization of the initial nano and submicrocrystalline state is currently debatable and requires further research. Therefore, the purpose of this work is to study the mechanism of the copper grain structure refinement upon doping with molybdenum and its thermal stabilization during subsequent annealing. The methodology of our research. Condensates of the copper-molybdenum binary system up to 50 micrometers thick obtained by separate electron beam evaporation of the constituent components and subsequent crystallization of their vapor mixers on a non-orienting substrate in a vacuum at a pressure of 10 to the minus 3 Pascal. Were studied separated from the substrate. It was carried out in a vacuum with a residual pressure of not more than 10 to the minus 2 Pascal in the temperature range of 600-900 degrees Celsius for 30 minutes. The structure was studied by transmission electron microscopy and X-ray diffraction. The molybdenum content was determined by X-ray fluorescence analysis. The substrate temperature was 450 degrees Celsius. The sizes of structure parameters were determined by the linear intercept method on the electron microscopic images. The choice of technological conditions for obtaining samples for research was due to the desire to create conditions for an equilibrium distribution of molybdenum atoms in the volume of the copper matrix during the formation of condensate during the deposition of the vapor mixture. The maximum dispersion effect on the grain structure of the copper-molybdenum condensates occurs at the molybdenum concentration of about 0.3 atomic percent. The results. Figure 1 shows the transmission of electron microscopic images of pure copper and our condensates obtained under the same technology's condition. The nature of the grain size of all samples indicates the occurrence of a recrystallization process during the formation of condensates, which corresponds to the selected technology's condition and the previous data. According to these images, alloying copper with molybdenum leads to a sharp decrease in the grain size of the copper matrix by more than an order of magnitude. The intergranular structure of the condensates is unfragmented since the grain size determined by bright field and dark field images practically coincide. Molybdenum particles with an average size of 1 and 2 nanometers are observed in the volume of the grains and at their boundaries. Besides, the electron diffraction patterns contain single diffraction reflection, which have a low intensity and belong to both the equilibrium BCC and non-equilibrium FCC crystal structure of molybdenum. The figure 1G. Moreover, the constancy of the copper crystal lattice parameter indicates the absence of molybdenum dissolution in the copper crystal lattice. On these images, obtained in the mode of registration of the characteristic X-ray radiation of molybdenum, this is the distribution of traces of its radiation, which make up certain areas. The average size of such molybdenum-free areas is about 120 nanometers. The presented results convincingly indicate that molybdenum atoms are located in the grain boundaries of the copper matrix, predominantly in the form of a monoatomic adsorption layer. According to some previous works, if the achieved grain size of the condensate during the deposition of a two-component vapor is limited by the blocking mechanism of atomic grain boundary segregation, then we can calculate a number of molybdenum atoms. You can see some formulas that we used for our research. After some transformations, we get the value of 0.2% molybdenum. Excess molybdenum atoms in an amount of about 0.1 atomic percent are concentrated in the particles observed on electron microscopic images. Figure 1. In the volume of the copper matrix, the particles are arranged in chains framing free areas. This morphology indicates that they are detached from grain boundaries, not preventing their migration by the Zener mechanism during condensation. Hence, an important conclusion about the mechanism of dispersion action of molybdenum on the grain structure of copper matrix consists in the blocking action of monoatomic adsorption layers formed on the surface of growing grains. Thus, it is energetically advantageous of the molybdenum atoms to form adsorption layers on the grain boundaries instead of forming self-phase particles or anomalous supersaturated solution in the copper crystal lattice. Figure 3 shows images of condensates after isothermal annealing. Up to a temperature of 800 degrees Celsius, there are no noticeable changes in the structure. After annealing at 800 degrees Celsius, the grain size slightly increases and molybdenum particles are still observed at the grain boundaries of the copper matrix, the average size of which is approximately 20 nanometers. The electron diffraction patterns show more intense diffraction reflection of BCC molybdenum, which have a crystallographic relationship with the FCC lattice of copper matrix. We mean the lines 110 molybdenum and 111 copper, which is typically for particles coherently connected with the copper matrix. Annealing at 900 degrees resulted in significant grain growth, and the increase in molybdenum particle size was observed. Those experimental results also indicate that the temperature of the start of grain growth of the copper matrix is limited not by the mechanical actions of molybdenum particles, but by the destruction of the absorption monolayer of molybdenum atoms, which initiates the subsequent growth of particles and grains. According to the paper Zinner pinning of grain boundaries and structure stability of immiscible alloys, we can calculate the grain size to the Zinner mechanism to work. You can see it right on your screen. Those means the theoretical estimate does not correspond to the experimental result we presented. So, what conclusions we can make? The grain size of alloyed copper condensates is determined by the blocking effects of the grain boundary segregation of molybdenum atoms, both during the deposition of the vapor mixture and during subsequent thermal exposure. Molybdenum particles located at the grain boundaries of the copper matrix can have both equilibrium BCC and non-equilibrium FCC crystal lattice. This state results from the formation of strong bonds between molybdenum and copper atoms at the internal interfaces. The structure of copper 0.3 atomic percent molybdenum condensates is stable when heated up to 600 degrees Celsius. At the temperatures above this, degradation of grain boundary segregation occurs, which initiates the formation of molybdenum particles of the BCC phase and the growth of the copper matrix grains. And this is all for now. Thank you for listening. If you are interested, please contact with us. We are glad to answer on all of your questions.
Dear colleagues, for your attention, presenting the work named Organization of the Structure of Composite Construction Materials and the Impact on the Characteristics of Concrete. Structure formation is an involuntary process based on physical, chemical, and mechanical processes and phenomena. Therefore, in order to obtain materials with predetermined properties, it is necessary to purposefully organize the initial structure and assign technological methods that make it possible to obtain final structures with the required parameters. Composite construction materials are complex systems of the structure within the structure type. At the same time, space-time structures of the qualitatively different types and scale levels arise in the system. The physical and mechanical properties of composites are determined by the type, number, and orientation of defects. Most of the defects are embedded in the material during the receipt. Such defects are called technological or hereditary. They retain the potential to develop when the equilibrium state of the system changes. The purpose of the work is to describe the organization of the structure of composite building materials at the micro and macro levels, to establish the causes of crack initiation and development of technological defects, and to describe the effect of technological damage on the physical and mechanical properties of concrete. It is interesting to determine the ways of managing technological damage in order to obtain materials and structures with standardized indicators. It is advisable to study the mechanism of crack initial on a representative volume of the system, which includes at least two neighboring K and N clusters. This is due to the fact that the probability at the appearance of an interim and relation to the system interface is higher at the boundaries of the interaction of structural blocks. Cracks that appear in the material at the micro and macro level automatically become cracks in the product or structure and thereby determine its deformability, crack resistance, and load bearing capacity. Therefore, it is important to establish the relationship between the damage of the material by technological cracks and its strength and strain characteristics. 18 concrete prism 10 to 10 to 40 centimeters in size were tested. The surfaces of the prism were tried with a toning solution to reveal surface technological cracks. The initial damage was determined using the area damage coefficient as the ratio of the total length of surface cracks. Estimate using a geometer L to the area of the sample S, where the measurements vertex Ks equal to L to S, is an estimate of the specific length of the crack that arose per unit area. The damage coefficient was all determined along a strength line h equal to 40 centimeters related to the length of surface cracks along it. K equal to L to L1 is an estimate of the specific length of the crack surface per unit length, where L is the length of the technological crack. The value of the damage factor of the prism varied within Ks equal to 1.3 to 2.08. K coefficient equal to 0.95 to 1.28. The prism at the time of testing had the same age. On this slide, you can see prism test 1, test shown. Three characteristics cases of the formation of adhesive and cohesive bond forces between the matrix and inclusion, which determines the mechanism of formation and distribution of shrinkage strengths, can be distinguished. 1. Adhesive to the matrix materials R to the aggregate is higher than its cohesive strengths. 2. Adhesive and cohesive strengths are equal. 3. Adhesive of the matrix to the surface of aggregates is below its cohesive strengths. Therefore, the formation of interfaces between the matrix materials and inclusions is determined by the nature of the adhesive and cohesive bond forces at the interfaces, the method of shrinkage, and the number of inclusions. A purposeful change in these parameters will make it possible to predict damage to the macro structure of composite construction materials by higher dietary defects. Let's consider the composition deformations of concrete. You can see prism compression strength depending on the damage coefficient. Let's consider the tangential deformations of concrete. You can see tangential strength of prism depending on damage coefficient. The inelastic composition strengths that acquire when holding the samples under load depending on the initial damage on the concrete are considered. You can see an elastic tensile strength of prism depending on damage coefficient. Let's consider the inelastic tensile deformation of concrete. You can see an elastic tensile strength of prism depending on damage coefficient. The resulting incipient crack is intercluster interface that can develop. The introduction of aggregates and the formation of mixed cluster structures can both contribute to the early appearance of incipient cracks and restrain their width, total number, and ability to grow. The formation of internal interfaces between the matrix materials and occlusions is determined by the nature of the adhesive and cohesive bond forces at the interfaces, the method of shrinkage, and the number of inclusions. A purposeful change in these parameters will make it possible to predict damage to the microstructure of composite construction materials by higher dietary defects. With an increase in technological damage, the values of total compression strength increase by 8 to 10%, tensile strain values increase by 25 to 40%. The values of inelastic compression strength vary within 8 to 22%. The values of inelastic tensile strength increase by 22 to 60%. Thank you for your attention.
Scientific work has brought to your attention numerical evaluation of the properties of highly efficient titanium porous material. The authors of the study are living scientists at National Technical University, Ukraine. We are glad to welcome you to the powerful and progressive 5th Graphicus International Conference on Advanced Manufacturing Process, InterPartner-2023. Titanium is characterized by the interesting combination of such properties as high strength, low density, corrosion resistance, and biocompatibility. Although the widespread use of titanium at the industrial level has not been achieved yet due to the high cost of extraction and production. Therefore, titanium is increasingly used in sectors with high demand such as aerospace industry or the production of biomedical devices where the final high cost is not a major factor. It's believed that the processing of titanium at its alloys using powder metallurgy (PA) method is a scientific way to reduce the cost of manufacturing titanium products and also provide the opportunity to develop new This work is devoted to the processing of titanium powder from biomedical production waste using various PA methods and is aimed at the research and the processing of almost pure, chemically homogeneous, and fine-grained titanium-based components. Titanium and its alloys are very important industrial metal. They are widely used in aerospace, energy, nuclear industry, food industry, chemical and biomedical engineering. However, titanium porous permeable materials consist of titanium metal and pores, which is why not only inherits the inherent characteristic of a metal, but also provides a number of operational characteristics, filtering, sound absorption, thermal insulation, etc. Therefore, the goal of our scientific research is a comprehensive assessment of the properties of highly efficient titanium porous materials for their use in biomedical engineering. The raw material was selected for the study Medgal, Biomedical Engineering Waste Poland. This company specializes in the development and manufacture of titanium implants. Therefore, the waste of this production is characterized by high material purity. The technological scheme of biomedical industry waste processing consisted of two stages, grinding and restorative annealing. It was developed at the Luz National Technical University and is protected by two invention patents. The results, starting powder material for the creation of titanium porous materials, are presented in Figure 2. Pressing and sintering of titanium porous materials took place according to the technology of dry isostatic pressing and sintering in the mode of high temperature synthesis, respectively. This is presented in Figure 3 and Figure 4, respectively. These technologies were also developed at the Luz National Technical University. In this way, it is possible to produce porous materials of their appropriate shape depending on the configuration. You can see on this slide titanium porous materials of cylindrical and cone-shaped shapes. The properties of porous materials based on titanium carbide are significantly superior to those of porous materials based on pure titanium obtained in the THS burning mode. The main initial and the main result of our research are the structure of the porous material, which is presented in Figure 6. Volumetric porosity due to packing of particles and microporosity of particles can be seen. The last circumstances allows to increase the specific surface of the porous material, and as a result, its suction properties, which is very important for PPA, which can be used for cleaning liquids and gases. The microstructure of the obtained material of Figure 6 allows us to state that during the metal reduction reaction, it is possible to obtain a porous material with a uniform structure. One of the most powerful and progressive methods of visualization obtaining 3D image data of the PPA structure is direct volume rendering the parameters of light emission and absorption, which are assigned to each point of the image. The slide presents the creation of a 3D image environment is carried out by superimposing flat cross-sections of the appropriate height range of the finished porous powder materials. Figure 7. Metallographic images of PPA grinding are represented by a combination of revised structural components. This slide represents results of 3D scanning. Images were first binarized using an automated sequence consisting of the image denoising, filtering, and thresholding. The images were then stitched together to give a representation of the 3D structure of the PPA monolith. Figure 8. The studied PPA sample consists of solid metal structure, monolithic skeleton upper with a porosity of 69%, interstitial voids shaded. Porosity can be determined from the number of black pixels that represent hollow space divided by the total number of pixels in the PPA structure. The advantage of the image reconstruction approach is its ability to produce spatial tortoise porosity. This makes it possible to study the distribution of radial and axial porosity, namely perpendicular and parallel to the axis of the cylindrically confined PPA monolith. Hardness is an important characteristic of a porous material that reflects the bond energy and symmetry of the structure. This slide presents results. The creation of the strands complex is the amount of specific potential energy of shape change accumulated by a deformed object. A dangerous state, fluidity, in the general case of a stressed state, occurs when the specific potential energy of a change in shape reaches its critical value. The next stage of the study of the strengths of titanium porous materials is its modeling. This is shown on the slide. With the help of abacus and entering all the necessary data, calculations are automatically carried out and the results of applying pressure from the outside are obtained. Figure 10. The details is displayed in a deformed form. Permissible loads on the titanium porous materials according to the maximum stress criterion are shown in green, and exceeded the maximum permissible loads is shown in red. Let's change the criterion to the criterion of destruction in abacus and display the pressure distribution. Figure 11. The modeling environment provides an opportunity to investigate and predict patterns of the structure formation and properties of porous materials, taking into account the sizes of the structural elements, establishing correlation between structural components. The result of our research is presented on this slide. Thank you for your attention. We are waiting for your questions and are happy to answer them. We are also ready for cooperation and joint scientific research.
The development of low-alloy structural steel with an improved complex of mechanical properties is a priority for automobile production, infrastructure building, gas oil production, and other industries. Increasing steel strength allows to reduce the weight of machines and structures with decreasing the materials and energy losses. It is a challenge for metallurgical industry to develop new high-strength steel grades and improve weight production technologies. The steel with strength over 550 megapascals are called advanced high-strength steels. One of the most famous and well-studied concepts of advanced high-strength steels is strip-assisted steels. They are basically manganese silicon steels with low carbon content subjected to post-tempering treatment. After heat treatment, a multi-phase structure consisting of ferrite, bainite, and retained austenite is formed on these steels. Austenite is able to strain-induced martensite transformation with enabling the trip effect. The trip effect is very important since it greatly contributes to the mechanical properties of steel. Due to the trip effect and a significant amount of protectoid ferrite, trip-assisted steel perform higher plasticity and formability. However, ferrite reduces strength, limiting the steel's application. The strength of the trip-assisted steel can be improved by partial replacement of ferrite or bainite with a stronger phase, namely martensite. This can be done using a heat treatment technology called quenching and partitioning, abbreviated as QNP. The classical QNP treatment mode involves the austenitization at temperatures above HC3, while the classical heat treatment of trip-assisted steel includes the intercritical annealing before austempering. Incorporating of intercritical annealing into the QNP mode can be feasible in order to increase the ductility of QNP-treated steel due to retention of some amount of protectoid ferrite in the structure. According to our previous research, performing intercritical annealing close to HC3 temperature ensures an important complex of strength, ductility, and impact toughness in 3-persisted steel. A microalloy with strong carbide forming elements: chromium, molybdenum, niobium, and vanadium. Due to limitation of carbon content in austenite before austempering. The latter hinders the cemented precipitation under binary transformation, leading to a significant increase in strength properties without loss of plasticity. This approach to austenitization can be also applied to QNP process. However, this issue is not well studied yet, especially regarding microalloyed 3-persisted steel. The aim of present work is to investigate the effect of temperature time parameters of QNP heat treatment, not on the microstructure and properties of 3-persisted steel, subjected to near-free and critical analysis. The research tasks are to reveal the effect of partitioning temperature on the mechanical properties of steel, to reveal the effect of partitioning duration on the mechanical properties of steel, to analyze the strain behavior and its correlation with the parameters of QNP model. The experimental steel overflowing chemical composition was used as a study material. Steels alloyed with molybdenum, chromium, and vanadium to maximize the benefits of QNP treatment. The specimens were subjected to QNP treatment scheduled in 3 stages, shown on slide. In the first stage, the specimens were austenized in 900 Celsius degrees for 10 minutes, which corresponds to austenite plus ferrite structure with a ferrite content of about 5%. In the second stage, the austenized specimens were quenched in a molten woods alloy below the MS point. In the third stage, the specimens were isothermally held in partitioning temperature to redistribute carbon between martensite and austenite. To review the QNP-treated steel's phase structural state and properties complex, the specimens were subjected to tensile and Sharpie impact tests, optical and electron microscopy, and XRD analysis. Slide 7 shows the microstructures of steel QNP treated with different temperatures at the partitioning stage. The microstructure has the same pattern consisting of martensite layers segmenting the former austenite grain. The layers are divided by ferritic interlayers. Increasing the partitioning temperature leads to a coarsening of the martensite with corresponding narrowing of ferritic interlayers. The microstructural pattern is the same for each temperature of partitioning in respective to its duration. More precise information on the structural features was revealed by TEM analysis. The observation revealed the internal structure of martensitic alpha phase featuring a high density of crystal defects, resulting from shear deformation under gamma ferrum to alpha ferrum transformation. Also, for all partitioning temperature, the structure consisted of the austenite films lying between the alpha phase layers. The film, like austenite, performed higher stability to strain-induced martensite transformation. This is beneficial for the mechanical properties of steel. Cemented inclusions were not found on the structure, being supposed by silicon present in the steel. The presence of austenite in the structure of QNP-treated steel was confirmed by XRD analysis. The XRD pattern for each partitioning temperature duration of 20 minutes exhibits all sets of diffraction maximum characteristic for gamma ferrum which FCC lattice, indicating the existence of austenite in the structure. With what alpha ferrum was a maillot phase, as follown from the comparison of intensities of the diffraction peaks. The calculation showed what the volume fraction of austenite after partitioning at 350, 400, and 450 Celsius degrees was 7.4, 7.3, and 5.3 volumetric percents, respectively, while the carbon content in austenite was 0.60, 0.90, and 0.23 weight percents, respectively. The latter values are from 3 to 4 times higher than the total concentration of carbon in steel, reflecting the enrichment of austenite with carbon during the partitioning stage, promoted by silicon inhibition of cemented precipitation from austenite. On this slide, the variation of mechanical properties depending on the QNP treatment parameters is shown. As you can see, partitioning at 350 Celsius degrees provided the highest yield tensile strength for more than 1000 megapascals after from 5 to 20 minutes holding. There is a tendency to decrease yield strength after partitioning for 30 minutes. The same tendency is observed for ultimate tensile strength with values length in the interval from 1,100 megapascals at the early stage of holding to more than 1,000 megapascals after 30 minutes holding. The highest ductility level was attributed to a partitioning at 400 Celsius degrees, ensuring the total elongation of 23.5% after 30 minutes holding. Impact toughness was a fairly high level, reaching up to 128 joule on square centimeter. The study of strain hardening rate has shown that steel performed a trip effect under tensile loading. This follows from increase in the curves at the second stage of deformation. This is associated with a trip effect. As can be seen, the strain hardening rate curves for different partitioning temperature perform the same behavior in the ascending section. However, they reach the maximum at different strains. That means that the strain hardening caused by strain-induced martensite transformation lasted longer, exactly at 350 Celsius degrees and 450 Celsius degrees, leading to more complete transformation of the tone austenite. In the case of 400 Celsius degrees, the hardening strain-induced martensite transformation stopped earlier. Thus, more austenite was retained in the structure, providing for higher ductility. The optimal combination of strain ductility and impact toughness was obtained after QNP treatment with partitioning at 400 Celsius degrees from 10 to 20 minutes. The mechanical properties of steel after processing according to this mode are presented on the slide. The high combination of tensile strength and elongation provide the product of strength and elongation up to 25 gigapascal on a process, corresponding to the advanced high strength steel level. The effect of QNP parameters on the structure and mechanical properties of low carbon structural trip-assisted steel, austenized near AC3 point, has been studied in this work. On this slide, you can read the main conclusions. This work was founded by the Ministry of Education and Science of Ukraine. The authors appreciate the support in the framework of EU Next Generation, EU the Recovery and Resilience Plan for Slovakia. The help of Professor Dabala and Mr. Mattia Franceschi with the XRD study is acknowledged. That's all. Thank you for attention.
Now we can discuss.
Dear colleagues, dear friends, we see the presentation of our works, and I invite you to join us for a discussion of the presented works. If you have any questions, please ask them here, or you can also write it in our chat. I have one question for Valentin Rebostan. Is Valentin here?
No, Valentin, and no co-authors in the chat.
Okay, they have time to join us. The authors of second book is here.
Yes, I'm here.
Nice to meet you, Natalia. Natalia, I have one question for your work. Could obtained results be used for, excuse me, do you hear me?
Yes, yes.
Yes. Could obtained results be used for prediction of damage structure of composite materials? And for which composite materials each work?
We studied it's for hard concrete. Constructions of hard.
Your results can predict damage structure of these materials.
This is on the study of research.
Okay.
We should study it on different composite of concrete.
Okay, thank you.
In this presentation, only for hard concrete. Cracks which appear when construction only process of hardening.
Thank you, Natalia, I understand. Is here of this job Alexander Kovstenoy or colleagues is here?
No.
Are the authors of force work, structure and mechanical properties here?
Yes, Vadim is in the chat.
Vadim Zurnadze is here, yes?
Yes.
Vadim, I have one question for you. Hello.
I had a problem with microphone.
Hello, Vadim. What are the main areas of steel application and how do you see the continuation of your research?
It's advanced high-strength steels. They can be applied to a lot of infrastructural areas. It may be automobile building. It may be any area which require a high strength of steel. Gas, oil application, etc., etc. Infrastructural buildings. This work is only in stage of investigation, and we do not work about future aspects of commercialization, application, etc., etc.
Okay, thank you. It's construction steel, yes?
It's low carbon construction steel, yes, you're right.
Carbon construction. Okay, thank you. Dear colleagues, have you any questions? Maybe somebody have questions to Natalia or to the Vadim. I see Hanna Zinchenko here. Yes. No.
I think we can sum up the results of this session because there is no other participants and so on. We can.
Okay, dear colleagues, dear friends, If you have no the questions, we have now finished our session, Advanced Materials 2. For my opinion, today it is very important to support our defenders as well as each other. Therefore, I want to thank everyone who attended our conference this year. Many thanks to Professor Volodymyr Tonkonogy, Vitaly Ivanov, and all InterPartner organization committee. I wish everyone good health, good luck, and victory on all fronts. Look forward to see you next year offline in Odessa on the 6th InterPartner Conference. Honor and glory to all Ukrainian defenders. Slava Ukraini!
Героям слава. Thank you very much to Professor Oleg Zabolotny for his involvement in this session, for his questions and discussions. I believe it will be beneficial and useful for our all efforts. Thank you very much for your participation.
Thank you. See you soon. Good luck.
Next session will be started at 11:25 according to the schedule. So next session will be Mechanical Engineering 2 and will be chaired by Professor Volodymyr Gury from Lviv Polytechnic National University. So join us a little bit later. The chat will be opened, so you don't need to disconnect. Stay with us.
Okay, may I start or not? Thank you. Good afternoon, dear participants of the 5th Grafton International Conference on Advanced Manufacturing Processes, InterPartner-2023. My name is Volodymyr Horay. I am Professor Dr. Science from Lviv National Polytechnic University. I am glad to welcome the participants of conference which is being held for the 5th time in such beauty city as Odessa. The wonderful city of Odessa feels the aggression of the enemy, aggression from Russian Federation. But despite such a difficult period of our life in our country, we meet to spend a nice time exchanging information to get a good emotion from work. This section will present mathematical models, numerical simulations, and experimental research. In our section, the reports scientists from the following institutes will be presented. Lutsk National University, State Enterprise Ivanchenko Progress, Zaporizhia, National Technical University, Kharkiv Polytechnic Institute, Tauria State Azov Technological University, State Biotechnological University, Warsaw University of Life Science, Poland, National University of Life and Environmental Science of Ukraine, separate subdivision of National University of Life and Environmental Science of Ukraine, Sumy National Agrarian University, Sumy State University, and Technical University of Košice, Slovak Republic. A lot of nice, interesting university will be present, and some of title I will introduce of our. I want to introduce some titles of our reports. It's a method of assessing of ultimately of mechanical characteristic of form. It will be the first. Second one, it's a numerical simulation of the natural frequencies depends of turbine blade, vibration of sine crystal anisotropy. The third, it will be experimental studies of the wear of the robots, working surfaces of a planetary hydraulic motor. The fourth, it will be the form of a spiral spring in a free state, and the last will be computer modeling of a cast processes for the centrifugal pump parts. Okay, now I want to introduce the first one. It will be the it will be a method of assessing of the optimately of the mechanical characteristic of form. It will be Olena Mikulish. Please, you are welcome. And we can start our conference from this first title. Please.
Hello, I am Olena Mikulic, Professor of Applied Mathematics and Mechanics, Department of Lutsk National Technical University, and I want to present the result of my scientific investigation about development of the method of assessing the optimality of the mechanical characteristics of forms. Modern technology solutions are increasingly implemented with using structurally heterogeneous materials. This is a significant increase in the use of foam, porous, and other structural heterogeneous materials in various shapes of life production, medicine, and other fields. The unique characteristics of such materials provide an extensive application of these materials in industry and domestic application. These structurally heterogeneous materials have a high energy absorption capacity, are useful for shock application, acoustic, and the thermal isolation problems. Basically, the results present in scientific research, most of which are experimental, are related to the evaluation of mechanical behavior or determination the mechanical or strength characteristics of some specific types of foam materials. This does not allow to generalize of the obtained results for other types of foam. However, the possibility of selecting optimal characteristic of structural heterogeneous materials to optimize the vibration absorption, heat isolation, and other characteristics of formed polymers is also have a scientific interest. Therefore, the aim of the research is to propose a method for assessing the optimality of the mechanical characteristic of foam materials. The task for this solution are present in the slide. Analysis of microstructure and result of experimental investigation of foam materials shows that the classical methods are not enough for the solution of statement problem. In the case of open cells, for modeling of these materials, the cell structure are used. Models of closed cells form are obtained by using polyhedron structure. Among the known approach based to study deformation in foam materials is an approach based on accounting of influence of shear rotation deformation of microparticles of the medium. Therefore, for developing a method for assessing the optimality of a microstructure of foam materials based on application of Cosseret continuum model is used. In addition, the development of such method required the obtaining of the model that would account for the nonlinear dependencies of the input parameters. In previous work, it is shown that with the low frequency load, the main contribution to wave propagation is made by the rotation shear wave that can be calculated based on this formula present in the slide. This formula contains the value of shear and rotation speeds, scale effects in the framework of Cosseret elasticity, coupler constants, and the value of characteristic frequency. The analysis of the result of experimental investigation of foam materials allows us to generalize the obtained value of mechanical properties of certain types of foam which are present in the table. To build a model that will describe the dependencies of the mechanical characteristic of the formed materials on the density and cell size, the dependencies of the shear modulus on these parameters was analyzed for some types of foam. The analysis of the graphic results shown on the slide confirm the need to choose nonlinear model to describe the relevant dependencies. Therefore, for building a model of the dependencies on the shear modulus of the form materials by the density and size, we use the Cobb-Douglas model. According to this model, we write the relation between the shear modulus and density and cell size in form for the determining the constants in this formula. We obtain the matrix equation which present in the slide. Using the proposed in the paper approach, the following was performed. Firstly, the value of the constants for the obtained model for determining the mechanical characteristics of wound are obtained. The reliability of the obtained model was checked by comparing the initial and obtained numerical results. An analysis of change in the mechanical characteristic of polyurethane forms at different density value and cell size, both within the study range and outside them, was carried out. The influence of the change in the mechanical characteristic of materials on the change in the speed propagation of rotation shear wave in form materials was studied. First of all, the proposed model was checked for accuracy. For this aim, we obtained a model for this value of constant and calculated the values of shear modulus using formulas of proposed model and compare these values with known in literature values. Obtained results confirm the effectiveness and accuracy of the numerical calculation. This approach allows not only determining the value of shear modulus at different values of density and cell size, both within the study, the range, and outside them. The results of the corresponding calculation are shown in the left figure on the slide. For the case, different value of the materials density and cell size. Also interesting are the results of modeling the influence of change in shear modulus due to the cell size on the materials at fixed value of density. The corresponding numerical results are shown in the right figure. In addition, proposed approach can be used for analysis the optimal characteristic of vibration absorption properties of the form. For this purpose, we will construct formulas for determining the speed of shear rotation wave propagation as a function accounting of the influence density, cell size, and frequency. Modeling of the characteristics within the coastal elasticity was based on developer approach. This characteristic were chosen as a function of density and cell size. The results of modeling changing in the speed of propagation and shear rotation waves as a function of frequency as shown in the figure on the slide. Analysis of the numerical results shows that an increase of the share modulus of the materials at the same cell size leads to an increase in the speed of propagation of share rotation wave, but increase in size of cells in the case of unchanged material density contributes to decrease the speeds of propagation of share rotation bands. Such simulation analysis allows to use numerical results for optimizing both the operation characteristics and the materials and of the materials and determining the optimal value of the density and porosity of the form to obtain the most desired results. Assessment of the impact of change in the speed of propagation of shell rotation wave in structurally heterogeneous materials allow to perform of optimizing the operating parameters of the corresponding element of construction to predict the optimal form microstructure. Using the apparatus of Kossert elasticity allows to model using analytical approach which afford accounting for the influence of the material's microstructure to control the accuracy and effectiveness of the numerical calculation. Features of the analytical numerical modeling method are convenient and practical for investigation of different types of form may be applied for investigation of other type of structurally heterogeneous materials such porous and granular. The advantages of this approach are the ability to evaluate the mechanical characteristics of similar form materials with different dose of polyurethane and the possibility to evaluate the mechanical characteristic of other widely used form in productions. First of all, we want to express our gratitude to the armed forces of Ukraine for the opportunity to provide the continuation of the scientific research. The work performs within the state grant of applied research and also expresses sincere gratitude to the Ministry of Education and Science Ukraine. We also want to express our gratitude to the organizer of the conference who are taking care of the development of scientific research in such a different time of Ukraine. Thank you for your attention. If you have some question, I with great pleasure answer for them.
Hello, dear colleagues. My name is Yevhen Nemanezhin, and today I'd like to introduce your topic of our research, which is a numerical simulation of the natural frequencies dependence of turbine blade vibrations on single crystal anisotropy. One of the biggest problems that arises in the development and operation of promising aviation gas turbine engines is ensuring the dynamic strength of its parts. Dynamic strength has a direct impact on engine life and reliability due to the fact that most defects are caused by the action of dynamic stresses from jump-like loads, which increase slightly when hit in resonance. Since the turbine blade is one of the most responsible and loaded parts of an engine, at the design stage it is necessary to assess and prevent the possibility of different resonant vibrations in the entire range of operation of the aircraft gas turbine engine. Because of the anisotropy of the mechanical properties of the single crystal, the crystallographic orientation has a significant effect on the spectrum of natural frequencies of the blades. The presence in the engine on the impeller of blades with different orientation increases the dispersion of natural frequencies. So the analysis of publications has shown that there is a significant gap in the application of modern finite element analysis methods for determining natural frequencies of turbine blade vibrations. In particular, there are almost no publications and studies on the influence of the orientation of crystallographic axis on the natural frequency spectrum of cooled blades. So the urgent need arises in developing such methodology for researching the dependence of changing elastic characteristics of monocrystalline blades on their natural frequencies and vibration mode. So here you can observe the flowchart of our research methodology, which includes 4 steps. The first step is obtaining the elastic relationship in a single crystal with different orientation of the crystallographic axis. The second step is getting 3D solid-state model and creating a finite element model of it. The third step is performing model analysis with pre-stress effects from centrifugal forces, and last but not least, building blade resonance diagram, which is also known as Campbell diagram. In the macromechanical analysis of products made of single crystal alloys, their material is considered as a homogeneous anisotropic continuum. The relationship between stresses and strains in an anisotropic body is described by Hooke's law in tensor form, as you can see in ratio 1. Where these components are strain and stress tensors in the adopted coordinate system, and this component is a tensor of the fourth rank, which characterizes the elastic properties of the material. For an ideal elastic body, the tensor of elastic constants has the following symmetry condition. It's right here. As a consequence of this condition, the number of different elastic constants is equal to 21. Depending on the type of symmetry of the material, the number of elastic constants decreases. For single crystals with cubic symmetry, 3 independent constants remain. The natural frequencies of blades made of single crystal alloys depend on the orientation of the crystal axis relative to the design of the blades. To obtain new scientific results on the establishment of such dependencies, it is necessary to obtain relations between the components of the elasticity tensor of a single crystal in various coordinate systems. The same relationships are also needed to identify the elastic constants of single crystal alloys based on the results of physical experiments. So the number of non-zero components of the elasticity tensor depends on the orientation of the selected coordinate system in relation to the planes of symmetry of the material. So let us choose the original crystallographic coordinate system in such a way that its unit vectors I1, I2, and I3 were directed along the crystallographic directions 1, 0, 0, 0, 1, 0, and 0, 0, 1 of the elementary cubic lattice, and you can see it right here on figure 1. To identify all components of the elasticity tensor, it is necessary to use the formulas for the transformation of the components of the fourth rank tensor when the coordinate axes are rotated. We will introduce a new rotated relative to the crystallographic coordinate system with unit vectors I.1, I.2, and I.3. So the position of new coordinate system relative to the original coordinate system is given by the matrix of direction cosines as mentioned in ratio 3. The components of our elasticity tensor constants in the new coordinate system are related to the components in the crystallographic system by the relation mentioned in ratio 4. If it's necessary for us to make a transition backwards from an arbitrary coordinate system to our crystallographic initial system, we can use inverse relations mentioned right here. When using our matrix form of Hooke's law, coordinate stresses and corresponding strains are written in the form of vector columns, and this relationship can be represented as square 6 per 6 matrix, as mentioned in here. The metric form of our Hooke's law is connected with matrix components here, and equation mentioned in previous slide with following relations, and they are right here. Turbine blades from monocrystalline alloys are usually manufactured in such a way that their longitudinal axis coincides with one of the crystallographic directions, for example 001 direction. By changing the orientation of the other two directions relative to the design of the blade, its mechanical properties can be influenced. In the coordinate system that coincides with the crystallographic directions, the matrix of elastic compliances contains three independent parameters. Other components of the matrix are zero at the same time. In this study, we will consider a partial case of change in the parameters of the matrix of elastic compliances when the selected system of single crystal directions is rotated by 45 degrees. In figure 2, here you can see the appearance of this matrix, and here you can see the ratios to determine some parameters of this changed matrix. And these ratios are used to form the initial data for the upcoming finite element analysis of natural frequencies of our turbine blade. On this slide, you can see the first set of calculations. Here on the figure, we see the temperature dependence of the components of matrix of elastic monocrystalline alloy compliances of typical heat-resistant turbine blade alloy. From this figure, we can calculate Young's modulus of elasticity, Poisson's ratio, and shear modulus. And here in this table, you can see the results of such calculation for different temperatures. On this slide, you can see the subject of our calculations. It's a 3D solid-state model of a turbine blade. It was created using Siemens NX software package. The second step of calculations was a finite element modeling using ANSYS software package. Here you see some parameters of this modeling. So the most significant one are type of LA element, which is solid 187. The size of the element was half a millimeter. Meshing method was patch conforming, and the density within the calculation was taken as this number. So here you can also see number of elements and number of nodes on finite element model. On this slide, you can observe the results of model analysis of the blade and the first four mode shapes of its vibrations and their corresponding frequencies. As the pre-stress effect for a model analysis, the centrifugal force was accepted and absence of displacements on the planes in contact with turbine disk were used. Here you can see the next set of calculations, which was constructing the resonance diagram for a cool blade of a high-pressure turbine. So here we see rotor rotation speed from 0 to 105%, which corresponds to 50,000 rounds per minute. So there are black straight lines with numbers here, which are harmonics of excitation forces from various factors in the process of engine operation. The blue lines are a graphical representation of dependence of our first calculated frequencies of vibrations on rotor rotation frequency. Here we can see a slight change during all the range. Also, there are green dashed lines which represent the natural frequencies of vibrations of the blade when the angle of rotation of the selected crystallographic system of directions is changed by 45 degrees. In this example, the rotation of the crystallographic directions creates the possibility to shift the second natural frequency at K23 harmonic by around 800 Hz, and the fourth natural frequency from the resonance at K40 harmonic here by around 2400 Hz. Then change in the first natural frequency was only about 200 Hz, which is not so significant. But at the same time, the rotation of the crystallographic directions couldn't help in avoiding the danger of resonance in 32 harmonic. On the previous slide, I mentioned rotating crystallographic direction system by 45 degrees to avoid dangerous resonant modes and showed the results of those calculations on our 3D model. And here are some tables with, for example, elastic properties of our heat-resistant alloy, which were calculated using our methodology described earlier in this presentation. And this table shows the results of calculation of natural frequencies of our initial crystallographic system and of the new crystallographic system of directions, which is modified and rotated by 45 degrees. In this table, you can see some significant changes in natural frequencies. So, in conclusion, I can say that for cooled blades with a complex cross-sectional profile, finite element analysis has an advantage over methods that use continuous functions to approximate displacement shapes. For example, such methods like Rayleigh-Ritz and Galerkin method. So our developed technique includes the procedure for determining the components of the tensor of elastic constants and the representation in matrix form, which is used in modern software complexes of finite element analysis. In order to make it possible to rationally choose the orientation of crystallographic directions during the manufacture of blades, we produce some convenient ratios of the transformation of elastic constants. The analysis of our research allows us to outline the task of further research on the optimal choice of the angle of rotation of the crystallographic directions and the development of technology for the manufacture of turbine blades. Also, the use of finite element methods opens us some opportunities for further analyzing fatigue strains of cooled blades with a detailed account of the stress concentration arising from the complexity of cross-sectional shapes of the turbine blades. So that's it for my presentation. Thanks for your attention.
Our sincere greetings to all the participants of the conference. Today we are presenting our findings on experimental studies of the wear on the rotors working surfaces of a planetary hydraulic motor. So, let us start with the introduction and major challenges. Planetary or orbital hydraulic motors are increasingly being used in various sectors of the national economy. For example, in the drive of rotary cleaners of the rot surface of communal harvesting equipment, in the drives of conveyors and rotary devices of grain harvesters, and in the drives of steering and running systems of self-propelled equipment, as well as in production lines of various types of enterprises. During the operation of planetary hydraulic motors, wear of the working surfaces of the rotors occurs. It has to increase in the diametrical gap between the rotors. In the case when the gap is less than the critical one, stable operation of the planetary hydraulic motor is observed. When the gap is greater than the critical one, The sharp deterioration in the functional parameters of planetary hydraulic motors is observed. Based on the study of literal sources, it can be argued that studies of the influence of wear on the working surfaces of the rotors of planetary hydraulic motor on its technical condition have practically not been given due attention. Let us move to the aim and research tasks. This research was devoted to issues related to the study of the effect of changing the diametrical gap between the rotors on the output parameters of planetary hydraulic machines in order to ensure their stable operation. To experimentally determine the effect of wear on the working surfaces of the rotors of planetary hydraulic motor on the dynamic of changes in its output characteristics with a change in the diametrical gap between its rotors, their mathematical apparatus was developed as well as the block diagram for modeling the dynamics of changing the output parameters of a planetary hydraulic motor. Theoretical and experimental studies of the dynamics of changes in the output characteristics of the planetary hydraulic motor with a change in the diametrical gap were carried out. Now, I'll present some points of the research methodology. When analyzing the change in parameters that determine the functional characteristics of a planetary hydraulic motor, the attention was drawn to change the three parameters: torque, rotation frequency of the output shaft of the hydraulic motor, and leakage flow rate. Depending on the change in the diametrical gap, the theoretical value of the torque is determined by the product of the resulting force from the action of the pressure of the working fluid F and the shelter of its application H. The real value of the moment, taking into account the error of the shape in the manufacture of the rotors, was determined by changing the value of the shoulder H by H sub I. During operation at values of the diametrical gap less than the critical, there are no leaks in the hydraulic motor due to the self-sealing of the discharge zone from the drain zone. When the value of the diametrical gap is greater than the critical value, leakage occurs between the rotors. Theoretical flow rates along the diametrical gap are characterized by the flow rate of fluids through a slot of height G'. The real values of the flow rate are characterized by an additional flow rate of liquids through a slot with a height G'. In the zone opposite to the diametrical gap G, due to a change in the value of the shoulder H by H sub I. The real value of the rotation frequency of the hydraulic motor shaft, considering the error in the shape of manufacturing the errors, is determined by the change in the value of the shoulder H by H sub I. Now let us go on with the results. The study of changes in the functional parameters of a planetary hydraulic motor was carried out by modeling the operation of planetary hydraulic machines using the block modeling system VSIM. To simulate operating conditions, a block diagram was developed. It allowed to determine the change in the output parameters of a planetary hydraulic motor when the working surfaces of its rotors were worn out. The input parameters for modeling were taken as follows. The working volume of the hydraulic motor was 630 cubic centimeters and pressure drop 16 megapascal. The output parameters of the planetary hydraulic motor were the torque determined by the block 1, the leakage flow rate determined by the block 2, and the rotation frequency determined by the block 3, where the above developed mathematical apparatus was implemented. This paper presents studies of changes in the functional parameters of a planetary hydraulic motor depending on the diametral gap from wear at three levels. The first level involved the theoretical studies for a planetary hydraulic motor whose rotors have a theoretical profile of cycloidal gearing, which is characterized by the absence of an error in the shape of the gear counter. The second level involved the theoretical studies for a hydraulic motor having a rotor with a real profile of cycloidal gearing, which is characterized by the presence of an error, the shape after manufacture. The third level was devoted to the experimental studies of a planetary hydraulic motor, the rotor of which has an error in the shape. The conducted studies have established that during the operation of planetary hydraulic motors, the working surfaces of their rotors wear out. Studies show that as the diametral gap increases, the theoretical torque decreases. Theoretical speed has significant deviations, up to 47%. The theoretical flow rate of overflows increases significantly. With a change in the diametral gap, the real torque sharply decreases by 42%, and the real flow rate of overflows increases sharply. The decrease in the actual rotation speed by 65.5% occurs as a result of additional movements of the inner rotor and an increase in the actual flow rate of overflows. Experimental torque, leakage flow, and aerational speeds change similarly to real values respectively, having the same numerical values. It has been established that the critical value of the diametrical gap is 2.5 times less than for the same value of a planetary hydraulic motor with a theoretical rotor. To make conclusions, we should state that the developed mathematical operators and the block diagram for modeling the dynamics of changing the output parameters of a planetary hydraulic motor allowed by modeling the operation process of planetary hydraulic machines to investigate the effect of changing the gap between the rotors and changing the output parameters of planetary type hydraulic machines. The coincidence of the results of experimental data and the results of modeling the operation of a planetary hydraulic motor with real rotors indicated the reliability of the theoretical prerequisites for the influence of wear on the working surfaces of rotor on the dynamics of changes in the output characteristics of a planetary hydraulic motor. The critical value of the diametrical gap for the first level was 2.5 times higher than the same value for the second and third levels. These differences show that the technology of manufacturing the gas surfaces of planetary hydraulic rotors has a significant impact on the dynamics of its output characteristics. Therefore, the improvement of manufacturing technology as well as the modernization of the design of the toothed surface of the rotors of the planetary hydraulic motor could more than double its surface life. Thank you for your attention.
Dear participants, your attention is invited to a report on the form of a spiral spring in a free state. First, we consider the bending of a residual strip under the action of a concentrated force P applied at the end of the strip. According to the theory of resistance of materials, the curvature of the elastic axis of the strip is directly proportional to the applied moment and inversely proportional to the stiffness of the strip. The stiffness of the strip is the product of the Young's models times the moment of interior of the strip's cross-section. In our case, it is a constant value. The moment is the product of the force P on the arm, which is the current length S of the strip. Under the action of the moment, the strip will bend. The curvature of the strip's axis will increase as it approaches the pinch point, since the arm and consequently the moment of force increase. Finding the shape of the axis comes down to integrating the equations. Even for such a simple example, the integration of the equations requires the use of numerical methods. When a force is applied to the strip, it becomes covered. The figure shows the angle to the current point M and the formula for determining it. If the force P is increased, the elastic axis of the strip will take the form of a spiral, which is called a clitoid. This means that you can turn a metal ruler into a spring, but its shape will not be rotational. The density of the coils of such a spring is very uneven. The distance between them decreases rapidly as you approach the axis around which the twisting occurs. Let's take a strip in the form of an involute of a circle of a radius a. Its natural equation is shown on the slide. And the spiral itself has a uniform density of turns. The density of the coils to each other depends on the constant A. When twisting under the action of an applied torque, the curvature of the elastic axis increases, as reflected in the curvature expression, resulting in a change in the shape of the spring. As can be seen from the figure, the density of the coils to each other increases as the length S to the spring increases, as approaches the center of the twist. The inverse problem needs to be solved. Find the shape of the spring's elastic axis in the free state, which after an applied force P will take the form of an involute. To do this, you need to apply a moment with the opposite sign to the elastic axis in the form of circle involute. Unwind the spring, which has the shape of a circle involute in its free state. This means reducing the curvature of the original involute from the applied moment. The expression of the curvature of the spring elastic axis in the free state is then as follows. The elastic axis of a spring that corresponds to the curvature has the following form. Therefore, the spring axis in the free state should be shaped as a spiral with the distance between the adjacent turns increasing in the direction of the center of torsion. For manufacturing spiral tape spring, it is necessary to have a shape of the elastic axis in free state. It should provide the absence of friction between adjacent turns during twisting the spring. If the elastic axis of the spring in the free state is constructed in the form of a spiral with the same density of turns, then when it is twisted, the same density is described. The distance between adjacent turns decreases in the direction of the spring twist center, which can help to friction between adjacent turns. To avoid this, it is necessary to form the elastic axis of the spring in a free state in the form of a spiral, in which the distance between adjacent turns in the direction of the spring twist center should increase. The calculation of the shape of the elastic axis of the spiral tape spring depends on the dimension of the cross-section of the tape, the Young's models of the materials, and the applied force that creates the moment. The calculation is based on the theory of non-line bending resistance of materials. Thank you for your attention.
Good afternoon, dear participants. I want to present the results of our research team's work titled Computer Modeling of Casting Processes for Centrifugal Pump Parts. Modern mechanical engineering requires rapidly updating the model range and design of centrifugal pumps with characteristics superior to previously created samples. It is possible to reduce the development time of pumps with improved features due to computer simulation. The application of computer modeling in foundry process is essential since many parts of centrifugal pumps can be manufactured by casting methods. The analysis of the main spheres of the Industry 4.0 concept showed that foundries are at the initial stage of its implementation. Because of the laboriousness of foundry processes, the number of input and output parameters it is the property of the final product. The number and type of foundry defects, so-called quality parameters, communication problems, and the mathematical description of several process stages. Improving the quality of products and reducing metal and energy intensity is an urgent task in the market economy of Ukraine. For this purpose, to reduce time and financial cost of production preparation, foundries began to widely implement computer modeling of the process of forming castings in the design of technology and the use of CAD systems in manufacturing equipment. The purpose of this work is a comparative analysis of the use of computer modeling in the foundry processes for parts of centrifugal pumps. So this research describes the application of computer programs for modeling foundry processes, casting metal blanks. Several casting objects of varying complexity were used in the simulation. A 3D model of the part and castings of a higher quality multifunctional mold for casting in the SolidWorks program was developed. Defects in drawings were also automatically eliminated. The NovaFlow and Solid and MagmaSoft programs were used to calculate the formation of shrinkage shells. The material for its manufacture was highly alloyed, corrosion-resistant steel of the austenitic martensite class, which has quite high strength and hardness, high resistance to plastic deformation, and good cold-resistant properties. Since this steel was alloyed during remelting for casting, it is essential to check its actual chemical composition after the solidification of the casting. A portable X-ray fluorescence analyzer and a stationary optical emission spectrometer were used to determine the chemical composition of steel after remelting. You can see its chemical composition in a slide. Obtaining the part guidelines refers to serial production, so it would be appropriate to use the casting method. The development of the technological process of manufacturing a part by casting consists of the following operations. First, it is obtaining cast iron, then production of steel by the duplex processes, then obtaining a casting in a sand clay mold, and finally mechanical and heat treatment. Formation in sand clay forms included the following stages. The model was covered with a special separation mixture. The lower model was placed into lower casting box 2 and fixed with false stands 4. The molding mixture was poured into the lower casting box and the excess quantity was removed. Gating system 6 was obtained and the upper casting box 1 was installed on the lower casting box. The process was repeated for the upper casting box 1, removed the profit model 3 and the model of the guidelines 5. Then the created imprint was covered with a thin layer of a special heat-resistant and non-stick mixture. In the place of the connector, a special separating sand was applied and the lower 2 and upper 1 casting boxes were fastened together. The model using a false stand is shown in the bottom left figure. After the formation is completed, the process of remelting the metal begins. Then the remelted steel is poured into a mold and cooled in the air. After cooling, the casting is taken out of the casting boxes and cleaned. The riser and the gating system are cut off. After cleaning the casting, it is inspected for cracks and other defects, and in the case of alloying during melting. The finished form of the obtained casting before mechanical processing is shown in the bottom right figure. The casting modeling process can be divided into 6 main stages. You can see them on the slide. The SolidWorks program was used to create a 3D model for of the guide apparatus part. This part module will be used to further design the 3D module of the casting and to further process the casting on CNC milling machines. Also, when developing a 3D model of a casting, it is necessary to consider economic feasibility. The upper right figure shows an example of two different models of the same part. It will not be economically feasible to use the model 1 since much more metal will be needed for such a casting, which will increase the cost of the part. Considering the requirements listed above when creating a 3D module of the casting of a guide vines, it is advisable not to increase the volume of the module itself relating to the part and to use only one central wooden riser. The bottom right figure shows the casting and gating system in gray and the riser in orange of the 3D module of the guide vines. After creating a 3D model of the casting of the guide apparatus, it is necessary to calculate the formation of shrinkage shells, which is performed in special programs NovaFlow and Solid and MagmaSoft. For NovaFlow and Solid and MagmaSoft software to work with 3D casting models made in SolidWorks, the model file must be saved in special format. The NovaFlow and Solid program, unlike MagmaSoft, is not able to work with the models that are divided into several solid elements, so it is necessary to create a separate composite model for it, which is a significant but not critical drawback of this problem since the creation of such a model takes more time. The results of shrinkage modeling in the NovaFlow and Solid program are shown in the figure in the slide. The main shrinkage is in the central riser, and there are defects in the area of the liquid draining canals. The NovaFlow and Solid program shows a small number of defects in the X-rays mode. Further calculations were made on the formation of shrinkage shell on the 3D casting model of the guide vines in the MagmaSoft program. You can see the figure in the slide. Almost all this shrinkage is in the central open riser and reaches almost its beginnings. This means that the volume of metal in the riser is enough to pull most of the defects on itself and simultaneously not to use excess metal to fill the castings. To compare this both program, it can be said that NovaFlow and Solid program is best used for checking simple and small models. It performs calculations quickly enough, but the accuracy of this program is low. Therefore, when calculating complex models, it may give incorrect results. When using the MagmaSoft program, more time is needed for the calculation process, but more correct results can be obtained. Also, the interface and functions of this program are more advanced and more convenient. Comparing the results of the formation of shrinkage shells during casting simulation using both programs, it was found that they practically do not differ. Therefore, this model can be considered successful. Based on the obtained results, it was shown that the stage of virtual design of casting technology before the production of castings allows to minimizing possible miscalculations and errors that inevitably occur in the development process, reducing financial and time costs, increasing efficiency, competitiveness, quality, and reliability of products. The main conclusions of our research can be seen on this slide. Summarizing the obtained results, we can say that computer modeling allows the creation of an optimal structure of the gating system at the design stage. Also, it avoids expensive operations of proving the technology and changing equipment directly in the process of organizing the production of the part. The authors appreciate the support of the Research and Educational Center for Industrial Engineering by Summa State University and the International Association for Technological Development and Innovations. My speech is over. Thank you for attention. Slava Ukraini.
Героям слава!
Thank you very much for your interesting reports with a beautiful presentation of materials, a deep explanation. I listened with a great admiration, and I'm sure that everyone was also interested too. Now we have a time for questions. You can ask to researchers some question by online or by chat. Okay, the first question will be maybe for the first author. The presentation was titled Method of Assessing the Optimality of the Mechanical Characteristic of Forms, but I'm looking for the first author, and maybe the first author is offline. Yeah, okay, we are going to the next one. The next one presentation was numerical simulation of the natural frequencies depends of turbine blade vibration on single crystal anisotropy. Okay, you are welcome for questions. Maybe any question from chat online. Okay, in a chat is free, but I have very short question. Have you been able to determine the accuracy of your modeling by using a finite element modeling?
Hello, do you hear me?
Yeah, I hear you.
Okay, yes, we checked the accuracy of our calculations. It was not mentioned in my report here in my presentation, but I work in Zaporozhye in State Enterprise Ivchenko Progress, and we are able to conduct some experiments on these blades that were mentioned, turbine blades that were mentioned in my presentation, and we checked the frequencies that we calculated during numerical simulation in ANSYS and on actual blades. And we got good results. So that's it, I think. Your microphone is turned off.
Oh, thank you. Thank you for your answer. I'm happy. Sorry, I really turned off my microphone. Okay, maybe any question for the second presentation? No, maybe everything is very clear. Okay, the third presentation was experimental studies of the wear of robots working surfaces of a planetary hydraulic motor. Okay, any question to this presentation? Maybe I will ask. I saw that the author of this work was online. My question is, on slide number 8, you can see a parameter G with 2 dots. How do you define it? Oh, Maybe something wrong with connecting. Okay, maybe we'll go to the next one presentation, or this maybe also will be more later, and give an answer for this question. Okay, presentation number 4. The form of a spiral spring in a free state. Maybe somebody have some questions to this author. Okay, when I looking for this presentation, I want to give one little very short question. What are the mechanisms to which research you applied? Can you apply? Okay. Sorry, but what about the number 4? I mean about presentation number 4. I saw that this co-author was in our chart. I'm looking for once more. Sorry, I'm watching a very little screen, but I saw some minutes ago this author. Okay, I will come back to the presentation number 5, the last one. Computer modeling of cast processes for the centrifugal pump parts. Maybe somebody have some question to this presentation number 5. Okay. I wrote some short question to this presentation too. How does the accuracy of these resultant workpiece parts improve? Christina, can you answer for my question? Or I have some problem with my microphone. Please help me. Give a question. Give an answer for this short question. How much improves is, or maybe how much does the accuracy of resulting workpiece parts improve? Or how does we improve the accuracy of these workpieces?
Hello, thank you very much for your question. And if you allowed, my co-author Tatiana Gavaron will answer to your question, but in Ukrainian language, if you allowed.
Okay, you're welcome.
Тетяна Павлівна, будь ласка, відповісти, яка була точність цих наших заготовок отриманих? Чи я правильно зрозуміла питання?
Yes, you are right. You translated very correctly.
Всім доброго дня. Скажіть, будь ласка, точність чого? Виконання моделювання цих заготовок чи точність їх отримання?
Отримання, саме отримання.
Ну, наша задача, в принципі, була зробити процес моделювання, і по ньому вже потім у цеху відбувається виливання цих заготовок за отриманими моделями. В принципі, програмне забезпечення, яке ми застосовуємо, дозволяє з високою точністю виготовляти потім моделі, і мінімальна іде доводка чи доробка, да, після отримання цих виливків цих моделей.
Дякую. Okay, thank you very much for your interesting reports. Once more, I'm very happy to take a part in this conference, and our work in this section has come to the end. Now there is a short break between sessions, and the next session will start as scheduled. I wish you all the best. I wish you all inspiration for work. Together we can do a lot. And I also believe in the power of our soldiers. Ukraine must win. Слава Україні! Героям слава!
Смерть ворогам. І я ще хотіла додати, I want to thank you from all our participants and congratulate you, dear Professor Volodymyr Gorey, with a successfully completed session, and wish you a future also success research works and also the peace of Ukraine.
Thank you very much. I'm so happy to be a part of this session, and see you in future, our Ukrainian scientific and international scientific works. All the best. Bye-bye.
Goodbye,
Bye.
thank you.
Thank you, bye-bye.
Can I start? Hello, dear friends. First of all, I'd like to appreciate your support of the 5th Grabchenkos International Conference on Advanced Manufacturing Processes. My name is Ivan Pavlenko. I'm professor of the Department of Computational Mechanics, named after Volodymyr Marcinkovsky, at Sumy State University, Ukraine. And I'm pleased to be the chair of the last 10th session in process engineering. Before presentation start, let me briefly introduce the session's key points. Our session consists of 4 presentations by 19 co-authors. Overall, the scientific teams are representatives of 10 higher educational institutes from Ukraine and Norway. The session aims to improve the ways to ensuring energy efficiency of heating systems, finding rational solutions in designing vibratory equipment, increasing energy characteristics of process superchargers, and evaluating the operating parameters of modified nozzles. Its primary goal is to extend state-of-the-art in dynamics, strength, and stability of mechanical systems, designing hydraulic systems, cast part, metal composite structures, and so on. Also, the session covers issues of wave propagation, vibration damping, failure detection, and dynamic stabilization of oscillation equipment. So now you have a great opportunity to watch all the presentations within our session, and after the last presentation, you will have an opportunity to ask your questions. And I offer to listen to all the presentations right now.
Hello, everyone. I am Galina Kabalava. I work at Admiral Makarov National University of Shipbuilding at the Department of Thermal Engineering. And now I want to present you our team research, which dedicated to investigate the combined heating systems based on heat pump for private residential building in the climatic conditions of Ukraine. The current state of the world economy is driven by an increasing demand for energy resources. But unfortunately, humanity has come close to a global crisis, not only in the world's fuel reserves, but also in the environmental situation. Many researchers and engineers propose measures to reduce heat losses and improve the efficiency of heat supply systems. There are some of them. The main can be to use modern equipment with higher heat generation efficiency, such as condensing boilers and heat pumps, and, for example, to optimize hydraulic modes of heating networks and others. So as you can see, it has been formulated the research tasks and ways to solve them. Then it was analyzed the meteorological data of the region where the building is located. It was south region of Ukraine. Then was determine the technical solutions for the electric heating systems, combination with an electric boiler, heat pump, and a condensing gas boiler. And finally, it was evaluated the effectiveness of solutions for electric heating systems of a residential building in comparison with traditional methods and identify the most rational ones. On the next slide, one of the working heating system is presented, which includes the combined operation of a heat pump and a boiler. First, 4 circuit solutions of the heating system were carried out. All of them were analyzed in a weather-dependent heat regulation mode. The first scheme was only a gas boiler. The second was with an electric boiler, and the third combine of a gas boiler and a heat pump, where the gas boiler turns on at outdoor temperature below 0 Celsius degrees and compensates for the heat deficit. And the last scheme was with an electric boiler and a heat pump, and the electric boiler turns on at outdoor temperature at 0 Celsius degrees. Outside air parameters, including temperature, were obtained from the resource meteormonths.com to analyze the influence of weather conditions. It is appropriate to establish the dependence of the outdoor temperature on the weather-dependent operation. Using meteormonths.com, data were obtained for the heating periods of 3 years, from 2018 to 2020. To calculate the characteristics of the heat pump, the obtained experimental data provided in the public domain were analyzed. It can be seen that the COP, or coefficient of performance, and the corresponding amount of useful heat degrees with a decrease in outdoor temperature, and increase with a decrease in the temperature of the heat carrying fluid. To simulate the characteristics of the heating system, like heat load or natural gas consumption or electrical energy consumption and others, depending on the change in outdoor temperature, the following input conditions were adopted. The maximum heat load of an electric boiler or a gas boiler corresponds to the outdoor air temperature not lower than minus 20 Celsius degrees. The calculations are made for the heating period from November to March, every 3 hours. Then the base scheme for comparing other options for the heating system is a scheme with a just gas boiler. And the last, the heat carrying fluid temperature at the heating system inlet was 35, 45, and 55 Celsius degrees. So results. Dependencies of the outdoor air temperature, natural gas consumption for a scheme with a gas boiler and for a combined scheme with a heat pump is illustrated. As you can see, gas consumption for a combined scheme with a heat pump is much lower. Then there are 3 diagrams with the dependencies of the COP and the heat load of the main equipment. As you can see, then the initial water temperature is lower the COP is higher, and at 35 Celsius, the coefficient of performance is almost 5. The results demonstrate that the total consumption of electrical energy for a heating system with an electric boiler is 35,000 kilowatt an hour. The load on the heat pump for the combined scheme is almost 15,000 kilowatt hour. So in this case, the total consumption of electric energy for the combined scheme with the load on the electric boiler was almost 15,000 kilowatt hour. So the reduction in electricity consumption per month reaches almost 5,000 kilowatt hour, which corresponds to almost 55% compared to the basic scheme. The lowest indicators of reduction of electrical energy correspond to November and March, which is explained by higher average temperatures during the day. Thus, it can be concluded that the use of an electric boiler is only rational when it is combined with a heat pump. Conclusions, the main of which is that the combining an electric boiler with a heat pump is the most rational solution, reducing the consumption of electric energy for the electric boiler, and it can and the reduction in electricity consumption per month reaches almost 5,000 kilowatt hour compared to the basic scheme. The presentation has been finished. Thank you for your attention. It's my pleasure to be with you. Thanks.
Hello everybody. Welcome to the presentation titled Using of Theory Similarity in the Project of Vibro-Conveyor Dryer for Grain, delivered by Igor Polomarchuk, Vladislav Polomarchuk, Mihailo Mostruk, Evgeny Petrichenko, and Evgeny Stefan. Introduction and Main Challenges. Traditionally, among the machines that accumulate all the given signs of efficient technological equipment, there are undoubtedly conveyor machines. For such a machine, the following essential properties are characteristic, such as continuity of operation, the presence of a load-carrying body, and others. Significant problems are the provision of mutual functioning of transport and technological links, and the possibility of increasing the level of mechanization and automations of such systems. A new technical idea, an essential sign of a conveyor vibrating technological machine, determines the possibility of its existence as such and the presence of a vibration technological action with the current method of organizing the machine operation. The effectiveness. Transport technological machines are efficiently carried out in the process of transportation and processing of the moving bulk product, drying, extraction, crystallization, and other heat mass exchange processes. The proportionality between transport and technological movement serves as a classification feature and determines both the perfection and the design features of the process equipment. The efficiency of the implementation, high potential, and prospects for improving these processes are observed precisely from the creative unification of vibrating conveyor schemes for transport technological processing. Aim and research tasks. The aim is the development of energy-efficient and reliable technological schemes for the implementation of vibration conveyor heat exchange processing of bulk products based on analysis of the main features, structural components, and development trends of vibrating transport technological machines. determination of the kinematic and power characteristics of the non-vibrating nature of the vibrating systems, substantiation of regional regimes of raw material advancement in the processing zone. Research tasks. Conduct an analysis of the relationship between the main structural elements of conveyor and vibration machines and establish the main trends in their development. Determine the main parameters of imbalance of oscillating systems and substantiate effective schemes of vibrational transport technological movement of bulk loading mass. Conduct an experimental evaluation of the parameters of vibration transport of loose masses of rapeseed and soybeans when using the development vibration wave infrared dryer. Carry out a comparative analysis of the results of experimental and theoretical research. Research methodology. When conducting research, a certain amount of whole rapeseed or soybean grain is fed to the belt, obtaining specific loading values equal to 2.3, 3.5, 5 kilogram per meter square, which determines the mass of products per 1 meter squared of conveyor belt area. After that, we set the tape in motion at the speed of 0.13, 0.33, or 0.54 centimeters per second. The power of the emitters is regulated by changing the current with the help of the laboratory autotransformer AOSN 20 to 120/75. Grain moisture is determined with the help of an Aqua 15 moisture meter, as well as from difference in the weight of the product sample and the weight of the same sample after drying it in an electricity drying cabinet. The vibration frequency of the vibration wave driver of the infrared dryer under study is measured using UNIT UT372 frequency meter. When performing experimental studies, German Robotron equipment was used to evaluate the kinematic parameters of vibration, electromechanical equipment to ensure a slow change in the frequency of rotation of the drive shaft of the vibration exciter, and a mechanism for stepwise changing in the eccentricity of the drive shaft was developed. Ready cooked sausage with vegetables additive. Please take a look at our research methodology using the conveyor vibrawave infrared dryer. Moving to the results, the equation of the investigated process of mass transfer in the criterion form looks as follows. Block diagram of the calculation of the intensity of mass transfer in the infrared drying of rape corpse. Moving on to the conclusions. Intensification of process of drying or friable lubricants of raw materials in modern technological process is realized with the application of radiation and inductive methods of heat transfer when combined with the convention of energy carrier when creating pseudo-liquefied layers of product, in particular under the action of vibrational impulses. According to the experimental data using the method of dimensional analysis and the Friedman-Buckingham theorem, a criterion equation for the process of mass transfer under infrared drying in a moving product layer, which is determined by the criteria of Pelkey, Stanton, Bordeaux, is a function that characterizes the productivity of the investigated process and allows you to form a recommended set of working mode. We thank you very much for your attention during our presentation.
Good day, dear participants. I'd like to present my report of work, energy characteristics of the oil vortex chamber supercharger. The problem of insufficient energy resources in European countries requires the development of high viscosity oil deposits located at a great depth. Very often, deposits with a great depth of occurrence are used irrationally due to the absence of a low efficiency of pumping equipment. Improving the oil pumping efficiency is a difficult task due to significant variety of composition, physical properties, and impurities that oil can consist of. As the efficiency of classic pump decreases, it becomes expedient to search for a new pumping technology based on jet technology. In general, jet technology has indisputable advantages: durability, reliability, and simplicity of construction. Therefore, further development of vortex chamber superchargers and research into their behavior during oil pumping can lead to perfect designs with high efficiency. There are several reasons for using jet technology in oil wells. Installing the jet ejector above the dynamic level of the well allows to stabilize of the supply of the electric centrifugal pump. Extraction of oil gas from the annular space of the well, which facilitates the rise of products to the surface. In general, vortex chamber pumps have significantly higher efficiency in pumping bulk mediums compared to the direct flow jet pumps. The VCP vortex chamber pump consists of a vortex chamber and 4 inlet and outlet channels, 2 axial suction channels, and 2 tangential inlet and outlet channels. The positive influence of the centrifugal force allows counting on an increase in the efficiency of the jet pump, with an increase in the hydraulic energy of the output flow. This is confirmed by theoretical studies and experimental characteristics. The purpose of the work is to determine the integral characteristics of oil pumping by the VCP and the effect on the characteristics of dissolved gas under different overpressures in the suction channel. Research tasks its mathematical modeling of the fluid flow, computational model verification, experimental study, and experimental and calculated data were compared with further modeling based on CFD approach. The study consisted of 3 stages: experimental confirmation of the proposed fluid flow, mathematical models adequacy in the vortex chamber pump, simulation of pump characteristics during the pumping of oil containing dissolved gas, and obtaining pump characteristics. Experimental investigations were carried out on a specially created experimental installation with a transparent vortex chamber pump, which made it possible to check adequacy and at the qualitative and quantitative levels. Mathematical modeling was carried out in the open form application program. The model adequacy based on the comparison of calculation results with experimental data was confirmed by comparison of pressures, flow rates, and efficiency. The mathematical model equations were the Reynolds averaged Navier-Stokes equations, the Rayleigh-Plesser equations for gas motion studying, the continuity equation, and SST turbulence model equation. During the research, an analysis of the solution sensitivity of the mesh was carried out. In total, the solution process required approximately 3,000 iterations. The last equation at the previous slide was used to calculate the release and growth of gas bubbles in the liquid. To compare the VCP performance characteristics, 2 types of calculations were performed. The first calculation is the influence of pressure at the suction channel, a mixture of oil and gas with a gas content of 5%, without considering the Rayleigh-Plesser equation, without a cavitation model. The second simulation was performed according to the above mathematical model of cavitation. The boundary conditions were as follows. Dynamic pressure was set at the input tangential channel, at the input axial channels, and an open boundary with a pressure 96 kilopascals, which allows the liquid to both enter the calculation domain and leave it without complicating the calculation. To simulate the pressure and fluids at the suction channels, the pressure value at this boundary varied in a wide range from 0 to 96 kilopascals. Dynamic pressure is set at the inlet channel. Physical properties of the liquid were for calculation. It's oil with a density of 850 kilograms per cubic meter and the dynamic viscosity of 0.004 Pascal seconds. Flow rates at all the channels were calculated during the calculation. To check the adequacy of the proposed mathematical model, a comparison of the VCP characteristics when it pumps air and water with the experimental characteristics was carried out. To determine the pressure in fluids at the suction channel, the study was carried out for 5 different pressures in relation to the pressure at the inlet tangential channel. An analysis of the maximum flow rate at inlet axial channels shows that as the pressure at the suction channel increases, the flow rate also increases. It can be seen in a figure that you can see at the slide, which presents the VCP characteristics. Increasing the gauge pressure at the suction channel to 0.27 allows for increasing the maximum suction flow rate by 44%. An increase in the relative suction flow rates does not allow for an increase in pump efficiency due to a decrease in outlet pressure. The pump efficiency was determined by the equation that you can see at the slide. Increasing the suction pressure reduces the relative net pressure at the pump outlet by 30%. The relative net pressure is calculated by the ratio of the net pressure to the working one according to the general equation for the jet pumps. A decrease in the relative net outlet pressure reduces the pump efficiency. In the area of relatively small suction flow rates, the efficiency and relative pressure increase for pumping options without using gauge pressure at the suction axial channel. Summarized information on the effect of the gauge pressure increase at the suction channel is shown at the figure. There is a linear decrease in the relative net pressure at the pump outlet in the absence of static pressure at the outlet. Also, there is an almost linear increase in suction flow rate, but with a greater inclination angle of the performance, which leads to an increase in relative efficiency. The efficiency of the serial industrial direct flow jet pump NSFB 3945 is approximately 3%. The obtained efficiency of the vortex chamber pump is more than 2.5 times higher than the efficiency of this pump. In addition, due to the use of the vortex chamber, the overall pump size is reduced by more than 3 times. At the slide, you can see the distribution of oil axial velocities in the pump flow part. The suction pattern is generally symmetrical relative to the horizontal plane in the case of the calculation without considering cavitation. It's possible to note the symmetry of the flow pattern relative to the vertical plane as well in the case of the calculation with the cavitational model. The simulation analysis shows a slight change in gas concentration for the case of the model without cavitation for gas release and a significant release of gas from oil in the case of calculation according to the model with cavitation. Features of two-phase fluid modeling allow to study of the kinematic parameters of each phase movement, and based on the results of the velocities calculation, it can be stated that neglecting the cavitation model leads to the fact that the gas concentration in the flow part of the VCP is very small and does not exceed 1%. It can be considered an inadequate result because the physical experiments prove that a decrease in pressure near the rotation axis of the vortex chamber nevertheless leads to a significant release of gas from the liquid. For further calculations, it's necessary to use the Rayleigh-Placer equation. The integral parameters calculation confirmed that the problem of obtaining flow patterns is the mismatch of the calculation results according to the different models. It should be noted that the value of the pump efficiency based on the cavitation model turned out to be significantly lower than without considering the cavitational model. It can be explained by the release of gas from the oil, which creates problems with oil suction into the pump. Another reason for decrease in efficiency can be the fact that in equation density is used to determine the efficiency, and in the case of a large gas concentration, the density of the mixture is significantly different from the density of oil, which can affect the accuracy of efficiency calculation. So at this slide you can see the conclusions, and on the basis of mathematical modeling by jointly solving the Reynolds Rayleigh-Placer the SST turbulence model equation and the continuity equation, the integral characteristics of oil transportation by vortex chamber pump and the influence of the suction pressure are obtained and solved. The vortex chamber pump efficiency is found to be more than 2.5 times higher than the efficiency of serial industrial direct jet pumps. The overall pump size is reduced by more than 3 times. Thank you very much for your attention, and you can ask me any question in next section of answering to the questions. Thank you very much.
Dear colleagues, my name is Alexander Shorinov. I represent a research team from National Aerospace University, Kharkiv Aviation Institute, and joint stock company Motor Siege. Among my colleagues are Anatoly Dolmatov, Andrei Volkov, and Konstantin Balushok. In our current research, we are focusing on understanding the effect of cold spray nozzle geometry on the particle impact velocity, and the possibility of controlling the process parameters in order to improve physical and mechanical characteristics of the coatings. The investigation of interaction of particle with a high velocity gas flow in the nozzle is an important stage in the development of technological process for coating deposition. The search for rational spraying parameters to achieve the required values of the particle velocity and temperature at the particle impact is necessary in terms of both the possibility of particle adhesion to the substrate and ensuring the given set of physical and mechanical properties of the coatings. It is quite obvious that process inside the nozzle is influenced by a large number of factors, and one-factor experiments, which are accompanied by large time and financial costs, do not always make it possible to reveal the pattern of process in the nozzle. In this case, numerical simulation is of considerable interest, not only from the point of view of determining the parameters of the two-pass flow in the nozzle and when flowing into the substrate, but also with the possibility of optimizing the geometry of the inner channel of the nozzle. One of the most important efficiency criteria that characterize any gas spraying based on the contact of high-speed particle with the substrate is the kinetic energy of the particles. In this regard, the kinetic energy of the particle, the nozzle outlet, should be selected as a target function for optimizing the process, and the characteristic particle size and linear gas flow rate from the nozzle should be selected as optimization parameters. The particle velocity is the most convenient for optimizing the cold spraying process. Analyzing the existing nozzles geometries for cold spraying and other features of the process, two important factors that had long been ignored were noted in our research. First, one of the features of the cold spraying process is the relatively small distance between the nozzle outlet section and the substrate. Secondly, the geometry of existing nozzles for cold spraying is calculated on the principles of achieving the maximum flow rate at the nozzle section, which create a powerful flow that reflecting off the substrate, slow down the particles of the sprayed particles, and prevent the particle from effectively taking over the flow velocity. So our team proposed a hypothesis about the possibility of improving the properties of coatings during low pressure cold spraying by providing high values of the velocity of the powder particles at the moment of contact with the substrate. The aim of our research is to analyze the velocity of aluminum and nickel powder particles in the channel of the modified nozzle for low pressure cold spraying, and compare it with the value obtained for a standard nozzle using the method of computational gas dynamics. The research tasks are shown in the slide number 3. Based on the standard spray nozzle, which is shown in figure 1, a new geometry of the flow part of the nozzle has been developed. Schematic images of standard and modified nozzles for cold spraying are shown in figures 1 and 2. The difference between the modified nozzle, which you can see in figure number 2, and the standard one, figure number 1, is that convergent part of the modified nozzle is short comparing with standard one. This results in the powder particles to accelerate more efficiently in the flow, which is faster than in standard nozzle under the same condition. Using numerical simulations for two-phase solid flow, the airflow fields is obtained by solving the Navier-Stokes differential equations using the standard turbulence model and the non-equilibrium wall friction. The system of equations includes conservation of mass, momentum, and stress equations. Calculation of powder particle velocity in the flow requires writing down the equation of the balance of forces acting on the particle. Governing equations are shown in slide number 5. After development of the nozzle model, simulations were performed at initial temperature T0 equal to 723 kelvins for aluminum powder particles with an initial pressure of 1 megapascal. The distance from the nozzle outlet section to the substrate was 15 millimeters to simulate a shock wave when the jet flow collided with the substrate. The calculation model of the modified nozzle is shown in slide number 6. Figure 4 and figures 4 and 5 show the result of numerical simulation with a contour image of the flow rate change at temperature 723 kelvins and pressure 1 megapascal in the channel of standard and modified nozzles. When comparing the results obtained, it can be seen that acceleration of the gas flow for standard nozzle, it's figure number 4, occurs along the critical cross section in the expansion part of the nozzle. For the modified nozzle, the initial flow acceleration is also observed along the critical nozzle cross section. Please take a look at figure number 5. The reduced length of the expansion part of this nozzle and an additional section with the constant diameter allow for further acceleration of the flow closer to the out section of the nozzle. Figures 6 and 7 show the graph of the velocity change for nickel and aluminum particle with the size of 25 micrometers in the channel of standard and modified nozzle. As can be seen from figure number 6, the velocity of 25 microns nickel particles at the exit from the modified nozzle was 364 meters per second, while the particle velocity was 325 meters per second for the standard nozzle at the same initial temperature and gas pressure at the nozzle inlet. For the aluminum particle with the diameter the same of 25 micrometers, an increase in velocity for the modified nozzle compared to the standard nozzle is also observed. As you can see, it is 492 meters per second and 429 meters per second for aluminum, for nickel particle. As noted earlier, the velocity is extremely important for achieving the required deformation energy of particles of the sprayed powder and as a result achieving necessary physical and mechanical properties of coatings. More intense deformation of particles in contact with the substrate occurs, a better contact with the surface and a higher value of adhesive strength. In addition, an increase in the particle velocity in contact with the substrate has a positive effect on the powder utilization rate. Let's sum up. Based on the simulation results, the flow velocity distribution patterns in the standard and modified nozzle were obtained, and graph of the velocity of aluminum and nickel particles in the flow were constructed. It was found that velocity of aluminum and nickel particles at the moment of contact with the substrate for the modified nozzle is 14 0.6% and 12% respectively higher than the velocity value for the standard nozzle under the same initial conditions. The novelty of the obtained result is that the influence of the geometry of cold spray nozzle channel of the particle impact velocity is demonstrated. The practical value is that obtained results can be used in the development of technological recommendation for cold spraying of coating for a modified nozzle and its further optimization. My colleague Andrei Volkov and me acknowledge the support from the project funded by National Research Foundation of Ukraine under grant agreement number, which you can see in this slide. Thank you for your attention, and do not hesitate to contact us if you have any questions.
Dear friends, first of all, many thanks for the interesting presentations. And now let me begin the interactive part of our session. So I'd like to remind and briefly discuss the primary findings obtained within the presented research works. After that, you will have an opportunity to ask your questions to each speaker. The first presentation was presented by Galina Kabalava from Admiral Makarov National University of Shipbuilding, Ukraine. She presented research on energy efficiency of combined heating systems based on heat pumps for private residential buildings under the climate conditions of Ukraine. Undoubtedly, the obtained results have practical significance and in reducing the specific electricity consumption by 35% during the heating period. However, we have one question from the internet. Which combination of equipment within for designing the heating system is the best in terms of reaching the maximum energy efficiency? Electric boiler, heat pump, condensing gas boiler, and so on.
Hello. Okay. We have investigated 4 schemes, and the best variant of them was to use electric boiler with a heat pump. This scheme showed the maximum efficiency of investigated scheme. So it was electric boiler and heat pump.
Thank you, Alina, for your answer.
Thank you.
Maybe other questions? There are no questions in the chat. So the next speaker was Igor Polomarchuk from National University of Life and Environmental Sciences of Ukraine. He presented the use of applied similarity theory in designing vibro conveyor dryer for grains. As a result of his research and his co-authors, the process of mixing particles during their transportation by wave propulsion engine provides heat treatment which eliminates overheating of the surface layer under the action on infrared irradiation. Do you have questions, dear participants? The author is not connected. However, we have one question in chat, so I will direct this question privately, maybe via email. So the next speaker was Andriy Rogovy from National Technical University Kharkiv Polytechnic Institute, Ukraine. He and his team evaluated energy characteristics of the oil vortex chamber supercharger As a result of the research, it was found that the oil vortex chamber pump efficiency exceeds the efficiency of the serial industrial jet pumps of the direct flow type by more than 2 times. Moreover, the pump's overall size was reduced by more than 3 times. So, dear colleagues, do you have questions? Okay, there are no questions. And finally, Alexander Shorinov from National Aerospace University, Kharkiv Aviation Institute, Ukraine, and his team numerically simulated a modified nozzle for cold spraying equipment. The novelty of the obtained results is in demonstrating the influence of the geometry of cold sprayed nozzle channel on the particle impact velocity. And the main findings can be practically applied in developing technological recommendations for cold spraying coatings for a modified nozzle and its further optimization. And we have one comment and one question from the chat. Please clarify the accuracy of numerical simulation results. And is it possible to analytically evaluate the parameters you have calculated numerically? Unfortunately, there is no speaker. So, dear colleagues, congratulations. Our session has completed successfully. Many thanks to all the speakers and participants. And I'm deeply convinced all the discussed issues and results will substantially impact the up-to-date trends in advanced manufacturing processes. And the primary outcomes will allow disseminating them through the international scientific environment worldwide. So I wish you a success to all the authors and speakers in their further research and professional growth. Thanks to everyone, and science unites people together. And now I'd like to give the floor to the General Chair of the conference, Professor Volodymyr Tonkanogy, to start the closing ceremony.
Dear participants of the InterPartner 2023 conference, our conference this year has come to an end. In my opinion, despite all the difficulties caused by the war in Ukraine, the conference was successful. Thank you very much to all the conference participants for your informative and important for science reports. The conference featured 53 reports prepared by scientists from 13 countries. This year we held 2 offline sections in the conference hall of the Odessa Polytechnic. All reports of scientists from Odessa, as well as scientists from Lviv, Kyiv, and Ivano-Frankivsk who came to Odessa were presented. More than 40 reports were presented online. I especially want to thank the entire InterPartner team for their clear and well-coordinated work. I am sure that next year we will hold InterPartner 2024 in peaceful Odessa. See you at InterPartner 2024. Thank you very much. Goodbye.